In the last part of section 13.2, we're looking at the continuity of a function of two variables. The function whose graphs are shown are continuous at every point in the plane. The surface f of xy equals 1/2 sine of the quantity x squared plus y squared. You see this function is continuous everywhere. You don't see any asymptotes or holes in the graph. This function is also continuous at every point in the plane. The function f of xy equals cosine y squared e to the negative square root of the quantity x squared plus y squared. Let's discuss the continuity of each of these functions. Part A is the function f of xy equals x minus 2y over x squared plus y squared. If x squared plus y squared were equal to 0, you would have an undefined, it would be undefined, so the function would not be continuous at x squared plus y squared equal to 0. And for part B, the function g of xy equals 2 divided by y minus x squared, well, y minus x squared cannot equal 0, so it would be continuous everywhere except for where y minus x squared equals 0. This is a graph of the first one, part A. F is continuous at each point in the plane except at the point 0, 0. Again, this problem was x minus 2y divided by the quantity x squared plus y squared. X squared plus y squared cannot equal 0. So the graph depicts this behavior in the graph, this asymptotic behavior, as you approach 0, 0. The second one, again, was g of xy equals 2 divided by y minus x squared. Y minus x squared cannot equal 0, and if y minus x squared equals 0, and you solve that, you get y equals x squared. The function is continuous everywhere except for where y is equal to x squared. On the graph, you see this depicted dotted line here, where y is equal to x squared. The behavior of the graph is asymptotic as you get closer to the equation y equals x squared. So we say the function is continuous at all points except those lying on the parabola y equals x squared.